So CPU register, which is shown in the figure, okay, 2.9. So this is your CPU registers. So this is not single register. Here you will be using many register under the CPU, which will be used for execution of instruction set. Okay. So for executing all the instruction present in the PIC microcontroller will be executed with the help of the CPU registers. So accordingly, before sense can be made of specific instruction, the use of these register must be understood. So before using all this instruction for the execution purpose, we have to understood the working of register. Okay. So in the direct addressing mode, several functions will be used for register. Okay, where you will be assigning two addresses for the register to access the data or for direct addressing. Okay, so direct addressing is nothing but a type of addressing mode, which will be used for addressing your register in the instruction set. Okay, so in the instruction you will give address of the specified register. Okay, for that purpose you will be using all this CPU register. See here W. So W is nothing but working register. So similar to your accumulator in the microprocessor, 8085 microprocessor, I think you learnt. In that you will be learnt about the accumulator. What is accumulator? So accumulator will be acting as a source register. It will be providing the data, or it will be acting as a operand, okay, for the instruction. So similarly here the working register will be used in the instruction set, many instruction as a source of operand. Okay, I think you all know what is operand. What is operand? In 8085 you will be using the instruction mov a comma b. Okay, so in that a comma bங்கிறது தான் என்ன operand. Okay, MOVங்கிறது mnemonics, A comma B is operand. Okay, A first operand, second operand is B. So likewise here W will act as a source of operand. That means you'll be getting the data. Okay, for doing some process. Move means any process, moving, going to move. Okay, or add, subtract. Likewise this working register will be used as a source operand in the instruction. Okay, it may also serve as the destination for the result of the instruction execution. That means the same register will be used for storing the result also. Accumulator also will be used for saving the result. Okay, result of arithmetic and logical operation. Similarly here the working register will be used for saving the result. Okay, so it serves as a function similar to that of the accumulator in many other microcontroller. As I said earlier, the working register will be similar to your accumulator performance. Okay, so the status register. Next, we are going to see about the status register. First, working register, one of the register in CPU register. Okay, CPU register has many type. So in that, second one is status register. So status register contain the C. C is nothing but carry bit. So here they given the example, 2-bit operands are added together. That is 10010001. So same bit going to be repeated for the second bit, second 8-bit. So these two bit going to be added. So add பண்ணா என்ன ஆகும் 1 1 1 0 வா 0. So you will be having the remainder 1. So 1 0 0 means 1 0 0 0 0 0 0 1 1 1 0. Okay, so here remainder 1 1 0 0 means 1 0 0 added now 0 1 1 added result will be 1 0. Okay, so finally we'll be getting the carry bit here. Okay, so two 8-bit going to be added, but you will have the result with the 9-bit. Okay, that is one is ninth bit is carry bit. Okay, if you convert this binary value into hexa value, that is nothing but 1001 is 9, 001 is 1. The same பிட்டுங்கிறப்ப 9191 hexadecimal add பண்ணா you will be getting this result. இப்படி add பண்ணக்கூடாது 1 plus 1 2 9 plus 9 18 like that you have you should not add it. Okay, you have to convert all the hexadecimal value into binary corresponding binary, and then only you have to add the hexadecimal value. So the result of binary value again have to be converted into corresponding hexadecimal value. So last 4 bit in a 0010, that is 2. 0010 also 2. So last bit is 1. Okay, that is carry bit. Okay, so if you get the carry bit, then you will be setting the carry bit value in the status register. See, they have given here status register. So address of status register will be 03 or 83. Okay, so each and every bit, this is the 8-bit register. So each and every bit in the status register is given here. So last two bit, that is 8th bit and 7th bit, because starting from 0 to 7. Okay, so அப்ப இதுதான் 8 bit, இதுதான் 7th bit. மேம் 7 6 இருக்கு, எனக்கு 8th bit 7th bit ன்னு சொல்றீங்கன்னு சொல்லாத. இது ஃபர்ஸ்ட் பிட், செகண்ட் பிட், தேர்ட் பிட், ஃபோர்த் பிட், 5 6 7 8. ஓகே, இந்த மாதிரி. ஸோ அதனால எயித்து பிட் இது. எயித்து பிட்டும் செவன்த் பிட்டும் பார்த்தீங்கன்னா ஆல்வேஸ் டிஃபால்ட் வேல்யூ வில் பி செட் 0. ஓகே, the remaining 6 bit will be this one RP0, that is register bank select bit. Okay, so this bit will indicate the uh, type of bank used. Okay, so I think in the register you have two banks, bank 0 and bank 1. So bank 0 na 0 இருக்கும், bank 1 select ஆகணும்னா 1 it will be represented in the sixth bit, that is RPO. Then not T not, what is that? Reset status bit. So status bit will be reset, not PD. Same thing, reset status bit. Z na 0 bit. If you get the result as a 0 when you are doing any arithmetic or logical performance, then your result will be 0, means you will be setting this bit as 0. Okay, DC na digit carry or borrow bit. Carry na carry borrow bit. So digit carry kum what is the difference? Carry bit means at the end of the addition you will be getting the carry bit. This is carry borrow bit. Okay, in subtraction if you get the get a borrow bit means you will indicate or set the bit here. But a digital carry borrow bit means in between. For example, in this you don't have any carry in between. இருக்கா இங்க இருக்கு பாரு. So 1 1. Okay, if you add 1 1 value, what will be the answer? 1 0. So 0, so you are getting one carry here in the next bit. Okay, so இந்த மாதிரி வந்துச்சுன்னா then your digit carry will be set as 1. Okay, that is digit carry. Digit carry is in between the bits while you are adding. If you have a carry means then it will be set as 1. Okay, இந்த carry வந்து last, at last carry occur ஆகுதுலையா, that will be represented. Okay, and then FSR. What is FSR? What is FSR? File select register. Okay, so file select register is the 8-bit register. Okay, here it will be point out the address of your memory. Okay, It will be used for addressing your memory device indirectly. And then indirect file register. So indirect file register means here the FSR will be used for addressing register indirectly. Okay, here they will be giving the address directly in the register, but here indirectly it will be represented by using the register FSR. Okay, to access the data from memory device. இதுவும் ஒரு 8 bit device தான். அடுத்தது PCL, sorry, PCLATH. Okay, so PC stands for program counter. LATH, LAT stands for latch. H stands for higher byte. Okay, so program counter is a 13-bit register. In that, 5 higher bytes will be represented by PC latch higher byte. Okay, that is 0 to 4 bits will be representing the PC latch higher byte. Okay, this one 0 to 5. And then program counter lower byte. This is lower byte. L stands for lower byte. PC stands for program counter lower byte. Okay, so program counter is a 13-bit storage device which will be pointing out the address, current location, memory location. And then here they represented the diagram, that is nothing but the PC latch higher byte address will be loaded into your program counter higher bits, that is 0 to 4. Okay, and then this memory address which is present in the PC program counter will be loaded into your stack memory. Okay, here they given for example 8 level stack memory. Okay, 8 level will be here. So in the current location, you will be loading the program counter address. Okay, that is given in the diagram. So these are the CPU register, status register, working register, FSR, indirect FSR, and then PC latch higher byte, PC lower byte, stack memory. So all this will be coming under CPU registers. So the explanation of the same how the carry bit, that is digital carry bit occurring, is given in the next slide. Okay, I think I don't want to explain. Okay, I will explain it. The 8-bit result is 2 2 and the ninth bit produces carry bit 1. Okay, they given this one, carry bit 1. Okay, if the ninth bit had been 0, then C equal to 0 would have resulted. Okay, if carry bit occurs, then as the ninth bit, then your carry bit in the status register will be loaded or set as 1. As a result of subtract operation, the C bit is cleared to 0 if a borrow occurs and is set otherwise. For example, they given for subtraction, if borrow occurs, then you that carry bit will be set as 1. Otherwise, it will be 0. That is given here. For 2's complement also, you can verify this same result. How means you are going to have the 2's complement for the above data value, that is 10010001, that going to be subtracted from this digital value. So subtract panna, the result will be this one. So now what we are going to means, we are going to add this result with the minune means this one. Okay, this data. So இதோட add பண்றப்ப you will be getting this same result, this one. Okay, for example 5 minus 3 equal to 2, now 2 plus 3 will give 5. Okay, the same thing they done here. Okay, this will be a result for adding minuend to the result of the subtraction. Okay, so by doing this, it will be indicating that the result of subtraction will not produce a borrow. Okay, this is proved in the by taking the 2's complement of the given data value. And then digital carry. uh, Digital carry is nothing but bit signal that a carry from the lower 4 bits occurred during an 8-bit addition. So இந்த மாதிரி ஆட் பண்றப்ப they given the example here. So இந்த மாதிரி ஆட் பண்றப்ப 4 bits ஓகே இருக்குல்லையா, இந்த fourth bit 1 ஆட் பண்றப்ப கேரி வந்துச்சுன்னா your DC bit in the status register will be set as 1. Okay, that is given here. So and then DC will be set as 1. The same thing will be repeated for addition of BCD numbers. BCD is nothing but, what is BCD? Binary coded decimal value. Okay, when you are adding two BCD value, then the result, if you have the carry in between the 4 bits, then it will be set as 1. Okay, for subtraction, BCD subtraction also you will be repeating the same thing. And then one more bit is 0 bit. Okay, 0 bit in the status register will be set as 0 when your result of any arithmetic or logical operation is 0. Okay, result 0 vanda, your 0 bit in the status register will be set as 1, otherwise it will be maintained as 0.